In this video, we are going to build a complete SpringBoot CRUD REST API that returns JSON and connect to MySQL database. So we will create endpoints for create, read, update, and delete operations and test everything live so you will be able to understand how it actually works. So to keep this simple, I'm going to start from the code we wrote in the previous video. If you already followed along, you can just open the project. If not, I linked the finished code from the last video in the description, so you can clone it and start from the same place. That way, we will be all working with the same exact setup. Before we add anything new, let's quickly look around the project so we know where the things live and all the things are working. So this is the standard Spring Boot project generated with Maven. All our Java code lives under the source main Java folder, and this main class here is the entry point of the application. For now, the important thing to remember is that controllers go over here and configuration lives under application.properties. We will come back to Rust. Next thing we need is a database. So we are going to set up MySQL for this project. I'll be using PHP MyAdmin here because it's simple and visual, but if you're using MySQL Workbench or Terminal, that's completely fine. The Spring Boot side stays exactly the same. All we need is PHP MyAdmin is create a empty database for the applications. We are not creating any tables manually. Spring Boot will handle that for us. I'm going to create a new database called SpringBoot CRUD. For that, so this is our PHP MyAdmin. Over here, I'm just going to create, SpringBoot CRUD. So click on create. So here, as you can see, no tables are being created. That's it for now. We need the database to exist. Now that database is placed, we just need to tell Spring Boot how to connect to it. All that configuration lives inside application property. So let's open that. So I'm just going to paste. Okay. So here we will tell Spring Boot where MySQL is running and which table to use. The first line in database URL, it shows Spring Boot CRUD, which means that that is the database which we created. So then we have MySQL username and password. Then DDL auto update to automatically create and update the tables based on our code while we are developing. And show SQL is equal to true. Just tell us see the SQL in the console, which is helpful while learning. At this point, nothing is visible happened yet, and that's expected. We created the database and connected the Spring Boot to it. The table will appear once add our first entity. Alright, now that the Spring Boot is connected to MySQL, we actually need something to store. In the first video, we talked about food delivery apps like Swiggy, where you place an order and the backend handles everything. So let's continue with that, the same idea. Think about a food item in a food delivery app. Each item has an ID, name, and a price. That's really all we need to get it started. In Spring Boot, we represent this kind of data using something called as an entity. An entity is a normal class, Java class, that describes what one row in a database should look like. So inside our project, I'm going to create a package called as entity. Okay. Inside it, another Java class which is called as food items. So now this is at this point, this is just a plain Java class. There is nothing special about it yet. So I'm going to add the entity annotation to tell Java Spring Boot that this class should be mapped to database table. So over here, going to add entity. So as you can see, some errors are coming in. Let's try to quick fix. There is nothing. related to configuration entity. So what happens over here is like in the POM file, we forgot to add one dependency, that is our JPA dependency. Okay, so once we add the JPA dependency, go back to foot items. Here still the error is coming in. Let's check what could be the reason. Let's try to click face again. Yeah, now import entity is coming in. So I just simply added the entity. Now next, in this class, we need to add couple of parameters. Uh, it's auto generated right now. Anyway, you can see, let's add int ID. That is the ID which we need for the product. Then the name, then the price. How much will it cost for the food item? So, and this ID should be auto generated. So, in order to do that, we are going to annotate with ID annotation. So, Jakarta persistence, it will get automatically updated. Next is at generated. So, then generated value. Okay. Now, inside it, we gonna define our strategy as generation type identity. Okay, so this three makes this ID as auto generated. Next, what we need to do is like set up the getters and setters. Here you can see, yeah, okay, that sounds good. This ID field is our primary key, and we are telling Spring Boot to generate it automatically for us. Then we have the name and the price, which are just the details of the food items you are expected to see in the menu. We will include an empty constructor also over here. So public food items. Okay. Because JPA needs it behind the scenes, and second constructor just to make it easier for us to create food items in the, in the code later. Okay. And the second constructor just to make it easier for us to create food items in the code later. Here is the important part. The single class is now acting as a blueprint. Spring Boot will use it to create the table in MySQL, and it will also use it to return JSON responses from our API. So this one class describe our data in Java, in the database, and in the JSON all at the same time. At this point, Spring Boot know what a food items look like, but we haven't saved anything yet. Now that the Spring Boot knows what a food items looks like, the next step to tell is how actually save and fetch food items from the database. This is where something called as repository comes in. So if you think back to the Swiggy example, the controller is where the order request comes in, but actually stores and fetching of food items happen somewhere else behind the scenes. In Spring Boot, that middle layer is called as repository, a basic helper that talks to database for us instead of writing SQL query manually. We'll just tell Spring Boot what we want and it handles the rest. So I'm creating a new package called as repository. Uh, Okay. And inside that, I'm going to create an interface called as food item. Let's make it as an interface. So we're gonna uh, extend uh, JPA repository, and we're gonna call food items. We're gonna pass food items and maybe long instead of. Here I am telling Spring Boot that two things, that this repository works with food items and the type ID type which is long. That's it. I don't need to write any methods right now. By extending JPA repository, Spring Boot automatically gives us the methods like save it, find all, find by ID, and delete. So we don't need to write SQL, we don't need to manage database connection, and we don't need to worry about queries or anything. Spring Boot handles all of these things behind the scenes. At this point, our application knows what a food items looks like, and it also know how to store and retrieve food items from the MySQL. Now that we have our entity and repository, we can finally expose everything through REST API. This is the part that turns our backend into something a front end can actually talk to. In food delivery app like Swiggy, this is where the app would request the menu and place an order, update an item, or remove something. So I'm creating a new package called controller, and inside that a class called as food item controller dot java. So we already have controller. Now food item controller dot java. Okay. So this class is annotated with a REST controller. This REST controller which tells Spring Boot that this class will handle HTTP request and return JSON responses. I am also adding base path of API slash food. So all our endpoints will start with that. Below, below at the REST controller, I'm going to add a REST request mapping. Request mapping here. Let's make it as API food items or make it as foods. This is our base. Let me quickly fix it. Yeah. Okay. So next we will inject food item repository using the constructor. So this constructor can talk to the database, the first endpoint to get the request with an OPAth. So this is our kind of fast food item repository. We will inject food item repository using the constructors. So this controller can talk to the database. The first point is to get a request with a no path, which returns all the food items. This is like fetching the full menu in food app. So for that, I'm gonna use as another function called as get all food items. So I'm gonna make it as public. List. We need to list as return, right? And what to return? Food items, right? Food items. Okay, awesome. So list, there is an error. I'm gonna quickly fix it. Utility. Okay, this will return all the food items. This particular endpoint. So, but we are missing one thing. Yeah, we need to give it as at get epic. Awesome. Next, we have a post endpoint, which let us create a new food items. This is like adding a new item in the bay. So in order to do that, I'm gonna make a post mapping request, then make it as public food items create, and I'm gonna save it. Then we have a get endpoint with an ID, which fetches a single food item. This is like opening the details of one specific item. So to do that, I'm gonna use get mapping, then inside bracket, no, curly bracket, I'm gonna pass ID. So what happens here is like, so when we pass the ID to the base URL, it will return food items using that particular ID. If else, it will return null. So something is like that. So that is what happening over here. Here, till here, uh, this is a what operation? Get all food. That is a read operation. So next, this is a, you know, post a food item. That is a create operation. Next, we have again a get ID. That is also a read operation. We have CRU. Next is update at put mapping. So we'll pass the ID, then update the ID, food items, then if we'll set the username, price, and save it to the repository. That's what happening over here. Uh, you can see over here. Okay. So this will actually update the food items by ID. That is update. This put endpoint which lead us an update of an existing food item. This is like changing the name or a price, something on the menu. And finally, we have an endpoint for delete also. So in order to do that, I'm gonna put it as, I'm gonna delete map it. I'm gonna pass the ID, public, then I put items delete by ID. Voila. So this delete endpoint, to be precise, I'm gonna comment something over here. Delete map. So this is like removing an item from the menu completely. At this point, we have a complete CRUD REST API for food items. Our backend can now create, read, update, and delete food items, and all using JSON and connect to MySQL. Now that our REST API is in place, let's actually test it and make sure everything works end to end. I'm going to start the application, and once it's running, we will send a few requests and see the real data flow through the system. So in order to start the application, I'll go to our entry point, then start the application. Uh, so we're going to run the application. I can see some errors, failed to load driver class, something. So I think in the poem we missed to add the, yeah, as you can see, I just added one dependency that is for MySQL connector that is used for MySQL Elite. So let me sing this and restart the application one more time. Let's see what happens. So once the singing is done, let me rerun the application. Okay. As you can see over here, the application is started with the 8080 port number and the application is actually running. So next what we need to check in the DB is whether this is getting added or not. As you can see over here, a new table is being added in the database for our SpringBoot CRUD database. So once that is done, we need to test couple of things, right? So in order to do that, let's go to our controller. Here we need to test a lot of things. As a CRUD operation, create, read, update, and delete all this operation we need to test. First is the create option. So let's say in order to create, this is the function we created for that. That is post mapping. Okay. So we will test this in the Postman. You can also use whatever application you like. Currently, I'm using Postman only. So I'm making it as a post request, localhost colon 8080 slash API. That is our URL. Then food, right? Food. So as you can see it over here, we define that foods. We should pass S also. Okay. So, and as we can see over here, we are passing one parameter that is food items. If we go inside food items, we have three values, that is ID, name, and price. Okay. And ID is a generated value, so it will generate automatically. We don't need to write anything. And name and price we need to pass, right? So for that, I'm gonna pass two parameters. One is name, let's say burger, then price as 1, 2, 3. So I'll send this information. As you can see, it give me a response, that is ID, name, and the price. I'll pass one more value, that is, let's say pizza. Let's call it as 53 as the price. I'm gonna send it again. Okay. As you can see, it returns ID do and name pizza and its price. Okay. What else we need to test? So I will go back to our controller. Here in controller, next thing which we need to test is C, create is done. Second one is a read, that is get mapping. Here we can return all the food items. Okay, get all food items. In order to do that, what we need to do, we'll create another request, localhost colon 8080/API/foods. Okay, let's send this, get request. Okay, you can see two items are coming, whatever we added in the request. In our previous, post request, all the items in the database is coming in. Okay, next thing what we need to test, let's go back to our controller. We need to test it with an ID. So get mapping/ID. We need to pass this parameter and see how it works. So let's create a new new tab. Over here, I'm gonna pass /1. One is for burger. So I'm gonna pass that information over here. Send this information. Some error is coming in. Let's see in the console what exactly happens. So yeah, as you can see, path execution wrapper present but cannot translate it in null value. Let me check how we are passing the request. Okay, got it. So here we are just passing it as an int. We need another annotation also. Let's try that and see. Okay, awesome. Let's restart the server, restart the application. Let's see how it works. So I'm gonna pass food one more time. Yeah, we are getting the one. Let's pass the second, that is our pizza. We are getting the pizza. Awesome. So next thing what we need to test is our put mapping. So I'm gonna change our request to put, then the same parameters, localhost, food, and we need to share the values, right? The first value is name. What and all we need to pass. One more thing which we need to pass, that is our /ID /1. We need to update the burger. So let's say I'm just changing its price to 133. So if I change just the price, let's send, what is the error? It's again causing that the same error which we had before. And we're gonna pass it as path variable once again. Let's see how it works. Okay, let me restart it. Okay, let me send this information once again. So name is passing it as null, because here we are not passing the name, so it thought that it is null itself. Okay, so let's say I'm gonna pass it as again burger. Okay, so yeah, burger comes again. Let's change it to 132 and send it. It got updated. Let's run the transaction one more time. Yeah, you can see the price got updated. Next thing what we need to do is delete, right? Delete button. So in order to do that, we need one more request, that is delete. Okay, so I'm gonna pass localhost foods and one value. Let's say let's delete our pizza. So if I send this information, again I'm getting the error. I need to change the parameter value at path variable. Awesome. Let me save this and restart the server, restart the application. Let me send this. Okay, awesome. Let me run all the transactions and see. Yeah, as you can see, it got deleted also. At this point, you've gone from simple controller to a real backend application with a database and full CRUD APIs. That's a big step. It is exactly how real-world backend projects are built. In the next episode, we will focus on making this cleaner and more robust with validation, proper error handling, response that look like more like production APIs. If you enjoy building this along with me, make sure you stick around for the rest of the series. Thanks for watching. I'll see you in the next one. Make sure to like and subscribe and put something in the comment section also.